Okay, so this is the section of notes, the video for the notes on box plots and dot plots. So go to your table of contents, and on the next section, so under the notes that you took yesterday, you're going to add box plots and dot plots to the table of contents and then turn to the correct page. And we are going to start taking notes. So box plots and dot plots are ways of showing your data, of displaying data. So we did our data review of our vocabulary terms, so now we're going to actually start displaying some data. So when you have a group of quantitative data, so numerical number data, we're going to create two types of graphs today. The first one is going to be a box plot. And box plot is a relatively new vocabulary term. We used to call it, so it's AKA, a box and whiskers. So we are going to make this box and whiskers plot, this box plot now is what we're calling it. And to make a box and whiskers plot or a box plot, we also do something that's called a 5-number summary. So a 5-number summary uses a lot of those vocabulary terms we learned or reviewed yesterday. So the first in our 5-number summary, there are going to be 5 pieces, is that we need to find the minimum. And remember, again, the minimum is the least value. After we find the minimum, the second piece of data that we use in our box plot is the lower quartile, which is the median below the median. So we identify the minimum, we identify the lower quartile, but before you can really identify the lower quartile, you have to skip to the third one, which is the median, which is the middle value. And remember, that's when data is ordered. So you can't automatically just start finding these values. You have to make sure that your data is in order from least to greatest before you start acquiring these 5 pieces of data. We find the upper quartile, which is the median above the median. And last but not least, when you find the minimum, you also need to find the maximum, which is the greatest value. And the thing is, yes, we've done box plots before. You've seen them before. We're taking it a step further because in algebra, when we're talking about quantitative data, when we're analyzing data, most of the time from here on out, it's not just going to be one set of data. You're going to have what's called bivariate data. You're going to have 2 sets of data that describe 2 different things. So you're using those 2 values, those 2 distinct groups, separate groups of data, and you're analyzing them. You're making comparisons. You're drawing conclusions. And one way to help you draw conclusions between 2 sets of data is by a box plot. So if we have 2 data sets, so let's do data set 1. And data set 1, I'll give it to you in order. Let's make life a little bit easier. 3, 3, 4, 4, 4, 5, 7, 7, 8, 9. So that's data set number 1. 3, 3, 4, 4, 4, 5, 7, 7, 8, 9. And then let's do data set number 2, and let's make that in order also, just to make our lives a little bit easier. Let's do 4, 4, 6, 6, 7, 8, 8, 8, 9, 10. 4, 4, 6, 6, 7, 8, 8, 8, 9, 10. All right, so we have our 2 data sets, and so we have them ordered. And so we're going to identify our values. So I'm going to really quickly just write minimum, lower quartile, median, upper quartile, and max, just so that we have a way of talking about and listing them out. So if I'm looking at the first data set, my first one that I want to find, even though it's the third piece of information, it's the first one I want to find. I want to find the median of data set number 1. And if I'm looking, I have 2 values in the middle. So I can add them together. 4 plus 5 is 9, divided by 2 is 4.5. Or since they're right next to each other, I can tell that the middle value is 4.5. It's also really easy to identify the minimum right away and the maximum right away. Now I need to find the lower quartile. And because I had a median that is not in my value, I include this 4. Even though it's one of my middle numbers, it's not my median value. So now I'm going to work backwards. 4 and 3, 3 and 4. So my lower quartile is 4. I'm going to do the same thing for upper quartile, and I'm including that 5 because that 5 was not in my median, right? My median's in the middle of it. So 5 and 9, 7 and 8. So my upper quartile is 7. I'm going to do the same thing for data set number 2. 4 and 10, 9 and 4, 6 and 8, 7 and 8. Again, I have 2 middle values. So my median is in between them at 7.5. My minimum is 4 and my maximum is 10. 7 gets crossed out, 4, 4, 6. So my lower quartile is 6. And then upper quartile, I cross out 8, 10, 9, 8. And I have 8 as my upper quartile. So after you do and find your 5-number summary, you make a box and whiskers point. And so here's kind of the code that you use. The minimum is a dot. The maximum is a dot. The lower quartile is a line. The median is a line. And the upper quartile is a line. So I draw a number line, and I want to include all of my data values. So 3 is my minimum and 10 is my maximum. So I'm just going to do 1 through 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And what you need to be really careful of is that you try your hardest to make your spacing even. So minimum, I'm going to put a dot, and it's going to float above the number line. I put a dot at 3. I put a line at 4. I put a line at 4.5. I put a line at 7. And I put a dot at 9. And I connect it to make my box and whiskers or my dot plot. And that's always how it is. From the minimum to the lower quartile, you draw a horizontal line. Lower quartile to median is a box. Median to upper quartile is a box. and maximum is a box. And Q, quartiles, means that it divides it into quarters, right? Your prefix is 25%. So 25% of the data is here. 25% of the data is here. 25% of the data is here. And 25% of the data is here. I'm going to do the same thing for data set number 2 on the same number line. I'm just going to put it a little bit above it. So my minimum is a dot at 4. My lower quartile is at 6, so I draw a line. My median is 7.5, so I draw a line. My upper quartile is 8, so I draw a line. And my maximum is 10. And again, from minimum to lower quartile is a line. Lower quartile to median is a box. Median to upper quartile is a box. And upper quartile to maximum is a box. And again, they're all 25% of the data. 25% is here, 25% is here, 25% is here, 25% is here. So what it tells me when there's a little tiny box compared to the length of the other ones is that there's a lot of data clustered between 7.5 and 8. Down here, it tells me there's a lot of data clustered in this. There's a lot of data in this very small space. There's a lot of data in this very small space, whereas this is larger, meaning that the data is spread out a lot in here. So these are box plots or box and whiskers plots or 5-number summaries. And typically we stack them. We have 2 together on the same number line so that we can easily look and see. If I'm looking at these graphs, I can easily say that data set number 2, the values are higher values. The data set is made up of higher values than data set number 1. So that's a box plot or box and whiskers or 5-number summary, right? Now we're going to move on to a dot plot. And a dot plot, again, is something that you've probably seen or heard before, just by a different name. So a dot plot can also be called a frequency table. So AKA, also known as a frequency table. You can even say that a dot plot, a form of it, would be a stem and leaf plot, right? Where you take your values and you put them ordered by place value. It shows another visual of just how many times something occurs. Frequency tables tend to have some bias to them, some misconception to them, because it's made up of dots. And students get a little out of control with the size of their dots sometimes. So again, just like up here in the box plot where you need to make sure that your intervals were really pretty close to similar, pretty close to perfect, you need to be really careful when you're making your number line. When you're making your dots, you need to make sure that, if you start out making dots that look like this, you don't all of a sudden end up with a random giant dot that makes your data look skewed, right? It's biased. It shows this dot doesn't look like it represents the same thing as the other dots. So we're going to make a couple frequency tables. It's going to be pretty quick and painless. So we're going to talk data set number 1. And let's do 10, 11, 15, 20, 22, 22, 24, 30, 31, 40. 10, 11, 15, 20, 22, 22, 24, 30, 31, 40. And let's do data set number 2. Let's make it 10, 11, 11, 19, 20, 21, 30, 32, 33, 34, 36. So let's talk in the scheme of dot plots first. Let's talk refresh, stem, and leaf. So a stem and leaf would be where you have place value divisions. So if I look, all of these are two-digit numbers, right? So they're all in the tens place. So I'm going to use my tens as my stem. So I've got a 1, a 2, a 3, and a 4. So that's going to be my beginning part. I'm going to put 1, 2, 3, and 4. And then, because I have 10, I'm going to put it 0. So that's 10. My next value is 11, so my 1 for my tens place is already there, and I'm going to put a 1 for my ones place, and that makes 11. And then I'll do 15. And I jump down to 20, 22, another 22, and a 24. And I have 30, 31, and I have 40. So I can make this a back-to-back stem and leaf by putting my data set number 2 on the left side. So I have 10, 11, 11, 19, 20, 21, 30, 32, 33, 34, and 36. And you want to try really hard when you're making these stem and leaves that the first value all lines up, and the second value all lines up, and the third value all lines up, and the fourth value all lines up, right? Because you don't want your data to not represent, or your graph to not represent your data accurately. I want to be able to look at the stem and leaf and say, oh, well, in data set number 2, there were a lot of values in the 30s and in the 10s. Compared to the pink data set number 1, most of the values were in the 20s. So you can compare, like if these were test scores, I would say that, data set number 1 had lots of students that did really well and lots of students that didn't do so hot. Whereas data set number 2, it was kind of spread out and more students scored in the 20s. To make a true dot plot, the dot plot is, first you want your line to be straighter than that. But the dot plot's a little trickier just in the fact that of making it double. You can go vertically and put some on top and some on bottom. I don't necessarily like to always do that. I'm going to try to do data set number 2 down here. It's going to take a little bit of finesse to try to get all of those values to fit on this number line. That's kind of the downfall of making these, is that you have to make sure that you can display all of your data. So, I could count by 2s. So I could do 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So I have all my values. They're a little squished together at times, but, we'll make it work. If I had the option, maybe like graph paper or using a ruler would help me to get those values ready. So I'm going to put dots for each one. So there's one value at 10. There's 2 values at 11. There's 1 value at 19. 1 value at 20. 1 at 21. 1 value at 30. A 32. A 33. A 34. And a 36. So this dot plot, right, I only have 2 stacked because there were 2 11s, but let's pretend that this data goes on and there were 3 more 36s. I'd want to space out my dots evenly. So if there was, 336s and 3 or 2, 334s, I'd want my dots to be even, right? I don't want to have one way up here because that makes it look like 34 has more values where it doesn't have more values. Some people use X's instead of dots. That's choice. That's up to you how you want to display that data. So the dot plot has some flaws to it, right? It has user or creator error, that if your dots are too big or your X's are too big or they aren't, the intervals aren't spaced enough, it can really mislead whoever's interpreting that graph. So you have to be really careful when creating dot plots. The last thing about this frequency table or this stem and leaf plot, you should always put a key anytime you make something like this, just so that people understand, because maybe this dividing line was a decimal. Maybe all the values were decimals. So you want to say that 4 with a bar and 0 really means the value 40. So again, it's kind of a review of the statistics of dot plots and box plots. But the new part is that we're adding 2 sets of values. We're using these things to compare 2 distinct groups so that we can then draw conclusions and we can then make assumptions and we can move from there into the more analytical part of the statistics.